In this video, we shall look at some of the techniques used in interpretation of instructions from a guest to a host in virtualization. In full virtualization, the source ISA of a guest system needs to be mapped to the target ISA of a host system. Even if the ISAs are the same, say Intel x86, the guest and host system may be in different states, and the virtualization software must keep track of the guest state and translate it to the host state. The simplest method to achieve this is through interpretation. Each source instruction of the guest is fetched, performed, and analyzed as an instruction on the target ISA. This is repeated for every source instruction. An interpreter is a program running within the virtualization software that has access to the source memory state as well as the source context block, which allows it to keep track of the guest system state and transform it to the necessary instructions on the host system. We'll now look at a few techniques used to implement interpreters, starting with the decode and dispatch technique. A decode and dispatch interpreter steps through the source program instruction by instruction and executes routines that perform the required translation of the source instruction to the target instruction. The central component of the decode and dispatch interpreter is the dispatch loop, which is basically a switch statement that selects the appropriate interpreter routine for the particular instruction to be interpreted. While simple, the decode and dispatch routine is not without overheads. The central dispatch loop becomes a bottleneck in the interpretation process, as a number of branch instructions are needed to select the appropriate interpreter routine. There are at least 4: an indirect branch for the switch statement, a branch to reach the required interpreter routine, a second register indirect branch to return from the interpreter routine, and a branch that terminates the loop. These branches lead to poor performance of the interpreter. One optimization to the interpreter to improve performance is known as the indirect threaded interpretation technique. In this technique, a portion of the dispatch code is appended to the end of each interpreter routine. An interpreter routine is located using a dispatch table and is reached by a jump instruction when stepping through the source program. Through this approach, the number of branch instructions can be reduced. However, there are overheads in this technique. The dispatch table still requires a lookup and a branch instruction. In addition, there is no caching of these target instructions, so the entire interpretation routine is repeated for every identical instruction in the source. In order to minimize the effort involved in interpretation of individual source instructions, a technique called pre-decoding allows for source instructions to be translated to an intermediate form that can be reused when the instruction is re-encountered for emulation. A target program counter is required to step through this intermediate code. An example of pre-decoding is shown here on screen, where each individual instruction is parsed and converted to an intermediate form so that it's easier to interpret it into the target ISA. An additional optimization in pre-decoding is to replace the address of each opcode of each instruction with the address of the interpreter routine. This leads to a new interpretation technique known as the direct threaded interpretation. In this technique, the overhead of interpretation is reduced as the instruction stream is pre-decoded and the interpretation routines themselves can be less complex and take less time to execute. The primary drawbacks of this technique include limited portability, as the intermediate form is dependent on the exact location of the interpretation routines in memory. This technique also requires a larger memory footprint, as the size of the pre-decoded instructions is proportional to the source memory image. In addition, the identical instructions still have to go through an interpretation routine, even if the work involved within each routine is reduced.